What do you think happens when you ram the unstoppable Indian plate into the massive Eurasian plate? You get the tallest mountain in the world, Mount Everest. You get global climate change, and you get huge earthquakes like the magnitude 7.8 in Nepal in 2015. And if you want to find out why the Indian subcontinent is like a Viking funeral ship and how its collision with Eurasia changed our planet forever, stay tuned for this Think video. Himalayas are huge and the Himalayas are beautiful. And it was plate tectonics that caused the Indian plate to crash into the Eurasian plate 50 million years ago. This violent collision created the highest mountains in the world, spreading across 1,500 miles. The Himalayas are so beautiful that many of its peaks are considered holy in both Buddhism and Hinduism. When we say plate tectonics, we mean the geological theory that the Earth's surface is made of many insanely massive plates which hold continents on top of them. All of these continents move. And you might think, but continents are huge, how can they move? Well, deep inside the Earth, it's hot, like real hot. And when that energy builds up, it creates currents of molten earth which make its outer shell, the continents, move. This tectonic process began probably about 3.5 billion years ago, after the Earth started cooling down. Our resident Earth science professor, Dr. Nigel Hughes, spent his entire life studying the Indian subcontinent and broke down the tectonic process just for you guys. You can find our interview with him in a link at the end of this video. Now, let's rewind 550 million years ago when the supercontinent Gondwanaland was formed. At the time, India was part of this supercontinent, as were Africa, Australia, Antarctica, and South America. Fast forward a couple of 100 million years later, and Gondwanaland collided with the Euro-American continent to form an even bigger supercontinent called Pangaea. Gondwanaland later disintegrated, which meant that India broke off and began to move northwards. As the Indian plate moved up, it passed over hotspots in the Earth's interior, which meant that India picked up a lot of speed. Imagine continental plates a bit like icebergs. Most of it isn't visible. Now imagine a big part of India's iceberg getting separated from the bottom. That happened, which meant the Indian plate got lighter and could pick up even more speed. And pick up speed it did, crossing 9,000 kilometers in 70 million years, all the way from the South Pole to its position in the north today. To put this into perspective, plates usually move about 5 centimeters a year. India moved almost 20 centimeters a year, and it's this unbelievable geological speed that explains the size of the Himalayas. The faster and harder the collision, the greater the impact. At the beginning of this video, we said that geologists likened the Indian subcontinent to a Viking funeral ship. What do we mean? In the days of the Vikings, if a high-ranking warrior died, their bodies were sent across the sea on a funeral ship with their most precious belongings. India, with its treasure trove of ancient fossils from Gondwanaland, traveled like a Viking funeral ship across the ocean. On the Indian subcontinent, early geologists found extinct fossils like Glossopteris, an extinct fern plant that looked like a tongue, or the weird-looking Lystrosaurus, an extinct herbivorous animal, or the hard-shelled trilobites. These fossils were also found in Africa, Antarctica, and South America, which indicated a historical connection between these places. These fossils were used as evidence for the existence of Gondwanaland, and also to prove the theory of plate tectonics. But India didn't only transport dead stuff, it also carried living stuff. As the Indian plate floated for millions of years, countless species roamed on its surface and evolved in many different climates. This created whales. Wait, what? Well, one of the coolest evolutions happened while India was getting closer to the Eurasian plate. Tiny deer-like animals that lived on its lands probably evolved to become whales. And when the two plates finally collided, the plants and the animals living on the Indian plate could spread and interacted with species living in Asia. According to Dr. Hughes, this kind of mingling and the changing physical environment offered the perfect boiling pot for biological innovation, that is, evolution. India's collision didn't just affect the ground and animals though, it also changed the local and global climate. Poetry about the great Asian monsoon cycles dates back thousands of years, with some of the earliest being Kalidasa's Sanskrit poem, The Cloud Messenger. This unique cycle of rain was kickstarted by the Himalayas and the Tibetan Plateau. You see, this whole area is so high up that it sucks in humid air from the Indian Ocean as one big high-pressure system. When clouds build up there and they get blocked by the mountains, seasonal rains fall heavily across the whole subcontinent. The Himalayan water system supports 1/5 of the world's population, and mighty rivers like the Indus, the Ganges, the Yangtze or the Brahmaputra were created in the Himalayas. All this water makes the Himalayas erode, and this eroded material has to go somewhere, right? Well, over the last 26 million years, the deposited sediment has gotten 20 kilometers thick, and that built the whole Bengal Delta. But there's one very big thing the Indian plate did just as it was colliding with the Asian plate. Before the collision, the Earth was what's called a greenhouse Earth. It was so warm that there were no ice caps in the North or the South poles. But after the collision, silicates in the Himalayan mountains started to absorb massive amounts of CO2 really fast from the atmosphere. And all of that meant one thing: global cooling. And as the Himalayas rose further, the temperature of the whole Earth fell, and so began the last ice age. Today, India's story is still unfolding. The Indian plate is still slowly moving and still plowing into the Eurasian plate, which means the Himalayas are still growing up, and this constant friction is also causing the crazy big earthquakes in Nepal and the surrounding countries. We're still figuring out how the collision changed our planet forever, but what we do know is that this event was, and continues to be, one of the key events in our planet's 4.5 billion year history. If you want to know more, watch our interview with the awesome Dr. Nigel Hughes on this subject. Extinct herbivorous animal, or the hard-shelled trilobites, an extinct marine anthropod, an extinct anthropod. Please, you've got to see, I mean, people. I mean, English.